Hello and welcome. I'm William C. Vantuono, Editor-in-Chief of Railway Age. With me today are two train control experts. The first is Deepak Kumar, Director of Marketing at New York Air Brake. Deepak is a certified project management professional. He holds a bachelor's degree in mechanical engineering and a master's degree in business administration. At New York Air Brake, Deepak is responsible for product strategies, new product development, and new product launches. Also with me today is Derek Call, the New York Air Brake engineer who developed brake cylinder maintaining, the first new function added to the freight car air brake control valve in nearly 50 years. This webinar will focus on this new control valve functionality as it applies to two important aspects of railroading, safety and productivity. Here are a few important things you should know in order for you to get the most out of this webinar. The presentation will take 45 minutes with 15 minutes available for questions. You can pose questions to the speakers at any time during the webinar. Simply type your question in the Ask a Question space below the presentation window. All questions will be answered, but our time is limited to 1 hour, so the questions we don't have time for today will be answered as soon as possible. Additional resources are available for download in the handout section of the webinar console. Finally, you can adjust the speaker volume in the audio window on the webinar console. And now I'd like to turn things over to Deepak Kumar. Deepak?
Thank you, Bill, and good afternoon to all our participants. First of all, on behalf of New York Air Brake, I would like to welcome everyone who has joined this webinar. I'd like to thank you guys for taking the time out of your busy schedules to learn about this interesting technology. I hope that the session today will meet your expectations. So what you will learn today is, number one, how air brake systems work, just a very high-level overview of that. You will also get a sense of how brake cylinder leaks reduce the safety and operational efficiency of the railroads, and then finally how the DB-60 with brake cylinder maintaining feature helps mitigate the negative impacts of ordinary brake cylinder leaks. So what I like to do first is to explain briefly at a high level about how air brake systems work. So what you see on your screen is a simple architecture of an air brake system on a freight car. Now, every freight car has a control valve, a two-compartment reservoir, and a brake cylinder. These devices are connected to each other as shown on the slide. There's actually a pipe that runs across the length of every freight car, which is called the brake pipe. Now, brake pipes on all freight cars in a train are connected to each other by means of flexible hoses. Now, this forms a long brake pipe connection that runs across the length of the train. The brake pipe is pressurized to 90 psi of air pressure, and this pressure is used as a signal for applying or releasing the brakes. Now, when this brake pipe pressure decreases, air flows from the reservoir through the control valve into the brake cylinder, and that's how the brakes are applied. On the other hand, when the brake pipe pressure increases, air flows from brake pipe through the control valve to the reservoir, and the brakes are released, and the system is charged back up to 90 psi. Now that you folks have had a basic understanding of how air brake systems work, let's talk about how the air leaks impact the brake system. Now, leakage in the brake cylinder line is very common, and it happens due to the environmental stress. So one of those stress points is the vibration. The vibration causes cracks in the welded joints and causes premature wear in air brake components. Now, over the life of the brake cylinder, there's normal wear and tear in the parts of the brake cylinder, and so leaks develop over time. And third, and the most important one, is the extreme temperatures. Now, as many of you may know, that air brake devices use rubber parts such as O-rings, packing cups, and diaphragms. And these parts act as sealing components. These spots at ambient temperature are quite soft and they hold the air without any problem, and the leakage is almost zero. But at colder temperatures, the rubber becomes very hard and its ability to seal significantly decreases and leakage becomes more pronounced. Now, often when a locomotive engineer is driving the train on a long, steep grade, they have to apply some amount of air brakes just to manage the speed of the train. Now, in those cases, when the brakes are applied for a very long period of time, the presence of leakage in the brake cylinder degrades the braking performance. We'll talk a little bit more about the impacts of this degraded performance later in the presentation. As we discussed, it's practically impossible to have a totally leak-free system because of the reasons that we just mentioned. Now, AAR, which is the Association of American Railroads, allows up to 1 psi per minute of the leakage in the brake cylinder. Now, each freight car is tested to this AAR test specification S486, which includes a brake cylinder leakage test, and every freight car is considered legal as long as the leakage is within the 1 psi per minute threshold. There have been several studies done to understand the extent of the brake cylinder leakage on freight cars. In fact, in 2011, at an Air Brake Association meeting, a study was presented that reported 138 cars out of the 1,043 tested had brake cylinder leakage, which exceeded AAR threshold of 1 psi per minute. Now, if you take this sample and apply the results to the AAR fleet of the 1.5 million freight cars using statistical techniques, we find that there is an average of 0.5 psi per minute leakage across the fleet. Some cars may have more leakage and some may have less than this average, but this clearly shows that the leakage in an air brake system is inevitable. As I discussed earlier, on long downgrades, especially in the winter conditions, the impact of the brake cylinder leakage can be pronounced. The current system cannot compensate for leakage, so the freight cars with the brake cylinder leakage would have reduced braking effort as compared to the ones that don't have leakage. Obviously, the overall braking effort of the whole train is reduced, impacting the safety and control of the train. Now, the freight cars that do not have brake cylinder leakage have to make up for the braking effort that is lost at the cars with brake cylinder leakage. Now, this causes additional wear and tear on these cars, such as brake shoes and wheels. Now, in order to maintain or manage the speed of the train, the engineer has an option to increase the amount of air brake, but many railroads have a threshold of how much air brake is allowed to handle the train on a grade. Now, if a higher level of air braking is required beyond the threshold, the engineer must stop the train, and this causes delays and reduced operational efficiency. Let's briefly talk about wayside detection systems, also called as hot box detectors. There are more than 6,000 of these systems installed in the U.S., and what these systems do is measure the temperature of each wheel on the train as it goes by it. During braking, heat is generated in the wheels due to friction, and a higher wheel temperature indicates application of brakes. Temperature on each wheel is compared to the average temperature across the whole train, and if the temperature of a certain wheel is lower than a preset threshold, the freight car is flagged as having cold wheels, indicating bad brakes. On the other hand, cars with sufficient wheel temperatures are deemed to have good brakes. When freight cars are flagged by the hot-cold wheel detection systems as having bad brakes or for repair, they are pulled out of service and sent to a repair shop. I would like you guys to watch a short video that explains how it works.
These systems operate based on a straightforward logic. When brakes are applied, they generate heat and raise the temperature of the wheel. Cars with cooler than average wheel temperatures are suspected of having substandard brakes and flagged, and taken out of service for inspection. Unfortunately, perfectly sound brakes are often flagged simply because they have not been fully applied due to lost pressure and leaks, as seen on long downgrades. Many of these same cars later pass the single-car air brake test in a warm shop and are returned to service without repair, needlessly resulting in lost productivity and increased maintenance costs.
In summary, if a car is pulled out of service and no defect has been found, railroads and car owners have lost time and money without getting any value. The amount spent in this process can be significant. Now that we have spent some time describing the problem, let's discuss about the solution. New York Air Brake has added a unique feature to its DB-60 control valve called as the brake cylinder maintaining feature. Derek will later on go into the details about what this technology is and what it does, but a few things that I would like to talk about is, number one, the BCM feature compensates for leaks in the brake cylinder, significantly improving safety. Number two, it complements hot-cold wheel detection systems such that the cars with only gross defects are flagged for repair. Number three, the BCM feature improves braking performance of marginal cars and keeps them in service longer. That way, the railroads and car owners get more out of their investment and the overall life cycle costs are reduced. As explained earlier, the BCM feature allows the braking effort to be maintained on long downgrades as brakes are applied for very long periods of time. It significantly improves the safety margin since the engineer does not have to apply a higher level of braking. Now, for rare and unexpected events such as loss of dynamic brakes, there's more air brake reserve that's left for the engineer to use. So just from a safety perspective, it's just a great feature to have. Now, in addition, it avoids delays and loss in revenue due to potential stoppages. Now, I would like to turn it over to Derek, who can walk you folks through the brake cylinder maintaining technology.
Thanks, Deepak. Now we are going to show you some video clips of how the overall system works. We're going to have a video on the uncharged state, another video for charging, and then finally we'll have a video on the brake cylinder maintaining in operation.
Here's how the DB-62 works. The DB-62 control valve on the car is connected to the brake pipe, with pipes running from the control valve to the auxiliary reservoir, the emergency reservoir, and the brake cylinder. There is also an exhaust vent to atmosphere in the control valve.
So the animation that you just saw was our system in an uncharged state. So at this point you will have 90 psi in the entire system.
System charges when brake pipe pressure increases and air flows through the valve and into the auxiliary and emergency reservoirs. At 90 psi, the system is fully charged and ready for use.
In this animation, you went from the uncharged state to the charged state, and you now have 90 psi in your reservoirs and in your brake pipe.
A service application, brake pipe pressure is decreased, and the valve allows air to flow from the auxiliary reservoir into the brake cylinder until the pressure in the auxiliary reservoir is equal to the brake pipe pressure. Brake cylinder maintaining occurs when the valve senses the brake cylinder is losing pressure. At this point, brake pipe air is allowed to flow through the service portion of the valve and into the leaking cylinder. The effect on brake pipe pressure is inconsequential, but the effect on brake cylinder pressure is significant. Up to 85% of lost braking power is restored. Air brakes are released when brake pipe pressure increases and air flows from the brake cylinder through the exhaust vent and from the brake pipe to the auxiliary reservoir.
So in this video, we showed you how brake cylinders can leak off and brake pipe will be used to maintain the brake cylinder. So the brake cylinder started at roughly 37 psi and reduced to approximately 21 psi, and then the new BCM maintaining feature maintained the brake cylinder. Okay, this slide shows our quick service limiting valve as we know it today. So the primary function of our quick service limiting valve today is to ensure that we have 10 psi brake cylinder pressure in all the cars during a min brake application. That is the primary function, but quick service limiting also acts as a brake cylinder maintaining valve, but it's limited to 10 psi. So if you look at the graphics where it's circled, there is pink air, which is the brake cylinder air, and then there is the orange air, which is brake pipe air. If brake cylinder pressure is reduced below 10 psi, the diaphragm moves to the left and opens the check, which allows brake pipe to replenish brake cylinder through a defined 30 thou choke. So now this is what BCM looks like today. As you can see from the graphics, for the most part, it's the same. The major difference here is the green air, which is what we call the reference chamber. We essentially gave the quick service limiting valve a memory. So now, instead of only maintaining to 10 psi, we can maintain through a full service application. So now if there is 30 psi in the brake cylinder and brake cylinder is reduced, the pressure in the reference chamber will move the diaphragm to the left and again connect the brake pipe air to brake cylinder. And again, this is still through the same 30 thou choke that is in the original quick service limiting valve. The other thing you can see on the screen is on the bottom right hand corner we have modified parts and new parts. It took us roughly 2 modified parts and 1 new part to introduce this feature into our service portion. So in the end, you're getting a highly reliable valve due to minimal part changes. So here we ran some simulations where we looked at the leakage distribution that we talked about earlier. It was a 150 car train that we basically ran a Monte Carlo analysis where we ran 1,000 simulations and looked at the percent of designed force. So an overall train is designed to have a certain amount of braking force to ensure the train stops, and this is the percentage of what was originally designed. So it's pretty easy to see with a 10 psi reduction and a 15 psi reduction in brake pipe that with BCM you will have a significant increase in percent of design force versus without BCM. So the blue line, or the dark blue line being with, and the green shaded area being without. In the end, with a 15 psi reduction, you're getting roughly, or you're maintaining roughly 87% of the design braking force. So here is some real-world testing that has went on with our BCM valve. Canadian Pacific Railroad did some investigations where they took 11 cars that were originally flagged for cold wheels and removed the service portion and installed the new BCM service portion. Placed the cars back into service and essentially took the cars from being cold wheels to being a little bit above average temperature. And that you can see that by where it goes from 70 degrees to 210 degrees. The dotted line is the average distribution of the train, and the green shaded area is where the 11 cars went to after new valves. So this is a good real-world example of the new feature making up for lost braking effort. So now I will hand it back over to Deepak.
Thank you, Derek. In addition to what you've learned so far, there are a few other things that I would like you folks to know. Number one, the new DB-62 control valve with brake cylinder maintaining feature meets all of current AR specifications. The control valve remains fully interchangeable with all the control valves that are out there in the field. We have over 500,000 DB-60s in the field today. This new feature does not adversely impact the single car test of today, so which is a good thing. Any existing DB-60 control valve that's out there can easily be upgraded with this new feature. And as Derek explained, there is just a few part changes, so it can be done very easily. And so, you know, the field valves that are out there can have the benefit of this improvement in technology. One other important thing to note is that this feature does not require railroads to change any of their current operating rules. And then finally, the product is available now. You know, we have sold already quite a few of those. And so, you know, it's ready for taking the benefit off. With that, you know, it's the end of our presentation. Again, on behalf of New York Air Brake, I would like to thank all of the participants for their time. Hope you folks learned about this technology. And with that, I will turn it over to Bill to facilitate the question and answer session. Thanks again.
All right. Well, thank you very much, Deepak and Derek. We do have some questions that have come in. And the first one, what is the impact of the brake cylinder maintaining feature on brake pipe flow? Does it limit the ability of the trains to leave the yard?
Okay, I'll take that one. So there's minimal impact of BCM on brake pipe flow, since the charging capacity of the quick service limiting valve choke has not changed. As I talked earlier, we go through a 30 thou hole, and that is still the same today. So old valves versus new valves, there is no difference or no impact difference on brake pipe flow.
All right. I think Deepak may have answered this question, but let me repeat it. Can existing valves be upgraded?
Yes, you're right, Bill. As we talked, the existing valves in the field can be upgraded, and this can be done at any certified service shop when the valves come back for COTNS, which is clean oil test and stencil.
Okay, here's a particularly interesting question. How will railroads test the brake cylinder maintaining feature?
So NYAB has proposed a supplement to the current single car test code S486 that outlines the special test to test this feature. And our the current single car test devices can easily be set up to test for this new test.
All right. Another question. How much leakage will the brake cylinder maintaining feature actually maintain? I guess in terms of PSI and time.
Yes, that's a very good question. So the simple way of saying it for me is if you have a somewhat of a smaller leak, like 1 psi per minute, you will be within 8 psi of target pressure. If you have a little heavier leak, like 2 psi per minute, you would be within 10 psi of target pressure. And this offset from the target pressure is due to how we decided to design our brake cylinder maintaining. As explained earlier, we went for a highly reliable, simple design. So in the end, there is a little bit of offset, but it's still a significant improvement in braking performance.
Okay, here's a question from a car inspector in the field. How is the product identified in the field?
I can take that one. So what we have done is our DB-60 with the brake cylinder maintaining feature has been assigned a new part number. The service portion changes, which is now called DB-10C. The previous version is only DB-10. So there is a DB-10C nameplate on the valve. There is a different side cover, and all of these are very clearly marked that if somebody was to take a look at the valve itself, it could be easily identified. The valve could be easily identified by anybody who looks at it.
Okay, and I guess a related question, does the interface of the valve change to the car?
No, it does not. The interface remains the same. This new valve is fully form, fit, and functional interchangeable with the current valves, and that's the beauty of it, right? These valves have to go in interchange service, and so it has no impact. So the interface remains the same.
Mm-hmm. Here's a particularly important question. Does this valve have full AAR approval or conditional approval?
I can take that one as well. DB-62 with brake cylinder maintaining feature at the moment has a conditional approval of 3,750 units. Obviously, New York Air Brake went through a full qualification process where, as we qualified the new design, we shared with the AAR the results, test results, and so on. And based on that, we got the conditional approval, which is a normal process. I would like to share with everybody that we have sold over 3,000 units already. So we are running out of our initial allotment, and we are in the process of working with the AAR to increase that initial allotment.
Okay. Another question, how will New York Air Brake test the BCM feature?
I can take this one. So currently when we do internal tests on this, assuming that's what we're asking, we would do a end-of-line production test, and as we test every valve, we would induce an artificial leak, and then we would check to see if the BCM feature is maintaining that leak.
Okay. Here's a good question. It must be from somebody, way up in Canada or something. It's getting cold up there. What is the performance of the BCM feature at minus 40 degrees Fahrenheit? Man, that's cold.
Yes, that is definitely cold. So, yeah, we talked earlier about low temperature being an issue, And one thing I can tell you is our BCM feature operates the same at room temperature and at -40.
Okay. I think just one more question. Has New York Air Brake added any new failure modes to the valve due to the addition of this feature, such as creeping up of BC causing wheel damage, or something like that?
No. Again, I'll go back on what I stated earlier. This is a simple change to our current design, so we get high reliability, and the failure modes essentially are the same as we have today. The current limiting valve in anyone's brake system today has the potential to leak brake pipe into brake cylinders, so that failure mode is no different than it is today. And again, we've done a lot of testing all the way down to -40 to ensure that we still have the same reliability with the new brake cylinder maintaining feature.
All right. I think we're just about out of time, but final question. Will the valve get rid of excess brake cylinder pressure?
Again, this one's a no. We are only maintaining pressure. We are not getting rid of excess pressure, and today this is no different on anyone's valve today.
All right. Here's another interesting question. How exactly does the brake cylinder maintaining feature maintain brake cylinder leakage?
So, as discussed earlier in the presentation, the feature will draw air from brake pipe through a fixed 30 thou choke to compensate for the brake cylinder leakage. And it starts feeding brake cylinder once the pressure in brake cylinder drops below the pressure that was generated during the brake application.
Here's a technical question about the valve itself, the brake valve. What has changed in the valve? What portion is the feature that has been added?
Good question. So we touched on this earlier. It's in the service portion, and we basically modified 2 parts, and we added 1 new part. So it was a slight change to our current quick service limiting valve.
Well, thank you very much. I'd like to, again, thank our 2 speakers for their highly informative presentations and also for taking part in this event. This webcast will be available on demand after a 24-hour period on the Railway Age website. But in addition to that, those of you who have been participating in this will receive an email when it's available. So thank everyone for taking part.